Alright guys, welcome back. So for our last step for solving the square one, we are going to cover edge permutation, which is where, for example here, we would put all of these edges back in the correct place, therefore solving the cube. So edge permutation is one of the steps for square one, at least, that's seen as having a lot of algorithms if you really want to get good at it because of all the cases that there is. But actually, for this step, all we need to learn is two to fully solve EP. Alright, so before we get on with solving EP, there's just one thing I want to clarify. So for some of these algorithms, instead of using the standard notation that we've been using with the numbers and the coordinates, I'll refer to an M2 move. So an M2 move is going to follow 1, 0, -1, -1, 1 like that. So 0, 1 at the end. So all that's going to do is flip both sides like that. It's kind of a quick little move like that we just got to kind of get used to, because it's going to be in some of the algorithms and it'll make the algorithms a lot shorter. Alright, so with that, let's get into the first case that we have, and that's going to be adjacent swap. So it's where we have two that are right next to each other in the front and the back. This is what we would call an even amount of swaps, so it does not include a parity error, right? We have one swap here and one swap here. So this is going to be the first algorithm we need to know, and it's actually pretty simple. So we're going to hold it one pair on the right and in the back, right, like that. We're going to do the algorithm -2, 0 slash 3, 0 slash -1, -1 slash 2, 1 slash, and that will fix our problem for us. So to show why this algorithm is so important for only learning this one algorithm, if we don't want to learn more specific cases here, we have a U-perm, which if we look here is going to be where the edges need to cycle like this, right? So this one needs to go here, this one needs to go here, and this one needs to go here. And we can actually solve this using our algorithm because there's an even amount of swaps that need to take place. There's one swap and then there's two. So let's take a look here. We're going to want to put the green-blue, which is our opposite here. We're going to want to put that in the back so that we swap these two. So we're putting the blue into there. So if we do that, we're going to run this algorithm with those two on the right because that's what have been swapped. Okay, and now what we'll see is we've kicked these two into each other like this. So we have an adjacent swap now on the bottom, but we also have one on the top. So we can just repeat this algorithm again and fix this problem. So that's how we would fix any type of U-perm where three edges need to swap on the top. All right, so now let's look at a situation like this. We actually see that we have a U-perm on the top as well as on the bottom, right? So how would we fix this issue using that algorithm? So what I'm gonna do is make sure that on the back and on the right, I have two, so that when they flip, I'll then have two that are right next to each other because we don't wanna make a line for ourselves. So we're gonna wanna hold it like this so that this blue is gonna go here, right? That'll be done, and then these two will just have to swap. So we can actually do this, we gotta keep this in mind for both layers so we can actually fix both at the same time. So we'll swap these two with this. So we'll do it again. Right, and then we're gonna have to readjust our layers here, but we have again an adj-adj swap that we can fix with that one algorithm. All right, so looking at another situation here, we see what we have. This is called an O-perm, where we need this edge to go here, this edge to go here, this edge to go here. So in a circle like that, that would be a clockwise O-perm that we need there. So I'm gonna attempt to use our swapping method here to swap these two edges and see what happens. So I'm gonna put them on the right, do the algorithm. Okay, so now we messed one up on the bottom, that's good. But now, I'm gonna try and swap this green into here so that we have this bar done, and then these two will be right next to each other. So let's go ahead and do that. Okay, so let's see what we have left. We have an adj here, and then we have no adj on the bottom. So this is what we call our parity error here, where we have only one swap that needs to take place, right? This can't occur on a 3x3. I actually made a whole video about parity if you want to learn a little bit about it, what causes it, but this is an error that we need to fix now. So up until recently, actually, I thought that the fastest way to be able to teach someone how to fix this error was just teaching them the algorithm that's going to swap these two edges and flip this bar. It's very long, right? And it's what I learned originally, and it's what I thought the best way to do it was, but so this is what this algorithm would look like. Like that, so very long, right? but I actually have an alternative way that we're going to use to just fix the parity issue, but not exactly just swap those two edges. So let's take a look at that. So to prove to you that this is going to work, I'm going to set up our adj-adj parity again here, or our adjacent parity here, and I'm going to show you, this is just an O-perm that's going to go clockwise for the algorithm, but it's the shortest parity algorithm as far as I know. So let's take a look at how we would fix this without memorizing that long algorithm. So we're going to do a slash 3 3 slash 1 comma 0 slash -2 -2 slash 2 0 slash 2 2 slash -1 slash -3 -3 slash -2 comma 0 slash 2 2 slash. Let's see what we're left with here now. So now what we see is we have a U-perm on top. So we fixed our parity issue because now we have an even amount of swaps. We're going to swap these two first. And now we can swap these two and these two. So we pull them in the right spot. And there. So that's going to allow us to fix our problem. We can flip our bar. And so that's going to allow us to fix the parity problem in any situation where we see it. So we might go over a few more of those, but any situation where you see parity, this will fix that problem. Okay, so if you want to be able to learn the least amount of algorithms possible, the adj-adj algorithm we went over first, and the parity fix, I'm going to call it the counterclockwise O-perm, are the only two algorithms that we're going to need to learn in order to solve the square one from there. So if this is it for you, congratulations. Keep practicing. I'd love to see some work there, but we're going to go over some more algorithms for those who want some easier situations to fix. All right, so some of these algorithms, they're actually not too bad, and they'll save you a lot of time from having to do a lot of adjacent swaps. So this is called op-op, so where we have this needs to swap and these bottom two need to swap, and this is going to be pretty simple in our M2 notation. So that's going to be M2, U2, M2, and we can do another U2 to get it back to the original spot. That's all we need to do to fix op-op. The next case is going to be called a Z-perm, so it's where we have an adjacent here and adjacent here. And we are free to just do a adj-adj there, and then we could rotate this over and do it again. But if you want the easier way to do it, honestly, what we're going to do is just M2, and we're going to be holding, these two edges on the front and the left that we want to swap with each other. It's going to be important for this. We're going to do a M2, U prime, M2, U, M2. That will easily fix our Z-perm issue. Alright, so this one's going to be the H-perm. For everyone that knows how to do 3x3 out here, it's where we need to swap these two and these two. So the algorithm for this is going to be M2, U, M2, U2, M2, U, M2. And that will be our H-perm solution. Alright, so now we're going to get into a few algorithms that I think that are just going to add some value if you already know all the other ones pretty well. And so this is going to be an opposite on top and an adjacent on the bottom swap. And this algorithm is also going to flip the bar in the middle, just as a note. But we're going to have 1, 0, slash 0, -1, slash 0, -3, slash 5, 0, slash -5, 0, slash 0, 3, slash 0, 1, slash. We can fix the top layer. So that case comes up a decent amount. It's a lot of adj-adj swaps, so if you want to avoid that, it's not too bad of one to learn. Alright, so I'm going to go over this pair of algorithms here. So actually what we have in these is we have a clockwise O-perm on top and an opposite on the bottom. So typically this is actually two pretty long parity cases if we do them individually, but this is actually going to be a pretty easy one that'll simplify our time a little bit. So this is the counterclockwise case we'll go over after. So because this needs to go clockwise, what I'm thinking is here we're going to do M2 U prime, M2 U prime, M2. So the way I think about that is we're doing an M2 on the front. We turn the U in the direction that's opposite of the way it needs to rotate. I think of that as the way to fix it, right? So we'll go over it for this one, for example, and then we just keep going with it. So this needs to go counterclockwise. So I'm gonna turn the up face clockwise here. So we're gonna do an M2, U move, clockwise, M2, U move, M2. And that is an easy fix for those otherwise nasty cases of O-perm plus op. All right, so here we just have our straight O-perms. So in this case, these need to go counterclockwise. This is the counterclockwise O-perm. This is actually what I said was the parity fix, but we're gonna go over it again. And this will be the clockwise O-perm where these edges need to move clockwise. So to repeat the counterclockwise O-perm, but it's just to fix this issue this time, we have slash 3,3 slash 1,0 slash -2 slash 2,0. So how I think of this is we are actually rotating this clockwise, right, to fix the counterclockwise issue here. So kind of the same kind of theme there. Then we do a slash, we do 2 slash -1,0 slash -3 slash -2,0 slash 2 slash. So when I stopped in the middle there, we kind of have that star on top. So for the counterclockwise, you're gonna rotate it clockwise, one of the units, one of the corners, 2. And you'll see for this one, it's honestly pretty much the same, but we're gonna go counterclockwise. So let's do the clockwise O-perm. We're gonna do slash 3,3 slash 1,0 slash -2. So the same up to that point. Now we want to go clockwise, so we're going to actually move this counterclockwise, -2 slash 2 slash -1,0 slash -3. So everything was the same up to that point except for that middle step, and now we just fix this a little bit differently. It'll be 1,0 slash 2 slash. So those ones seem long, but they'll help you avoid the longer adj-adj and op parity that we're gonna go over now. All right, so for straight parity algorithms, we have our adj swap here. The only time I'd recommend doing this or even learning this is if you only see adj here, right? It's the only time it's probably the fastest. Otherwise, I would just use that parity fix that we learned in the beginning. So let's go through the algorithm though. So we're going to have a slash -3,0 slash 0,3 slash 0,3 slash 0,3. Okay, so that was 4 three type moves in a row. So then the next part is going to be 2,0 slash 0,2 slash -2,0 slash. So that was 3 moves in a row that had a 2 in it. And then we have our 4 moves. So we're going to move the top 4,0 slash. Okay, that was 1, and now we have some 2s. So we're going to do 0, -2. So just move over these edges here, slash, go right back, 0,2 slash. And then we're going to do a -1, and then a 4 on the bottom, slash, 0,3 slash 0,3 to fix. Whew. All right, so let's talk about our last pure parity swap here, and it's going to be our opposite swap here. If we don't like the opposite swap, we can do 2 adj-adj algorithms and get it into just an adjacent algorithm if we wanted to, or we can just do the O-perm counterclockwise. But I'm going to show you how this algorithm is actually really similar to the O-perm counterclockwise, the parity fix that we talked about, and how it's nearly not that much different. So we're going to start the exact same way for this. Right, we have this in the front and in the back. We're gonna do slash 3,3 slash 1,0 slash -2. Okay, so just like the counterclockwise O-perm here, we're going to do a 2,0 move here, slash, then we're gonna do a 2 slash, and this is where things get a little bit different. Okay, so we're gonna do a 0 -2, so we're actually gonna turn to this corner, over this corner here, slash. We're going to realign things by going -1, -1, slash, and then we're going to do a 0,3 slash. We have a kite then, so we can just go -3, slash, then we're going to do a -2 slash. Then we're going to do a 2, 2 slash. That will fix that. Alright guys, so that is all the EP algorithms that I actually know. So I kind of threw that out there. We got to remember that we got to do this step by step because it's definitely going to take a long time to get through all these edge permutation algorithms. But the first two are obviously going to be the most important. I wanted to mention that that's not all of them actually. There's a lot more, which like I mentioned, there's a lot of EP algorithms, but these are the ones that I feel like will get you through most of the cases. A lot of it's going to be practice, a lot of adj-adj swaps for certain things. I wanted to mention something like this, which actually I don't have the algorithm memorized for, but it would be really useful, where we have a U-perm on top and we have an adj swap on the bottom. And if we kind of followed what we did here, we know that this is an even amount of swaps and this is an odd amount of swaps. This is actually a parity case right here. And there's an algorithm that solves all this in one step that I don't have memorized. And so I'm just trying to make a point that there is some cases that I don't have all the cases memorized, obviously. I put out a list that I thought was a good amount to learn, but there is always more challenges like this, and yeah. Alright guys, thank you for watching my edge permutation guide. To end the video, I just wanted to do a quick example solve where I'll walk through what I'm doing, just so you can kind of see my process. I'm definitely going to be doing some more example solve videos, but I wanted to throw one in here. Alright, so when we start with cube shape here, what I'm seeing is that when we line these slices up, these are paws, right? We slap it together, we're going to get this double scallop. So I can line those up like that. For the edge orientation, I'm going to kick this bar up like here, so we have an L. I can put the unsolved corner here. We want the solved corner down here, so we can swap them like that. I'm looking for any bars. I see a bar in the back, and that's it. So what we're gonna do is hold this on the left, and then we're going to do the algorithm that we learned from edge permutation to get that around. This is a pretty bad EP case, I'm not gonna lie, but what we see here is it's a U swap, so we need 3 to swap here, and it's a double U there. So what I'm gonna do is I'm gonna position this here so that orange completes this bar, and then I'm going to make sure that the red goes over here. So I want these two on the back and the right, so I'm going to swap those, and then I can see that I have just an adj-adj here, so I can do the algorithm again. And then we just need to flip the bar to solve. Alright, so that was kind of a full walkthrough that included everything that we went over in these guides. So I'm going to be doing some more example solves soon, maybe some more stuff at Square-1, and we'll see what's next. Thank you guys for watching.